the same idea. Let us solve question number 9 from question number 1 in the EOT. Now again, I will start with the same exact steps. Step number 1, I am going to find delta x. Delta x is b minus a over n. Now in the question, a is given to be 0, b is given to be 3. So I will say 3 minus 0 over, we are doing n equal 4, so I will put over 4. So delta x is 3 over 4. Now step number 2, I will draw a line. This line will help me specify my points. The starting of the line is A, the ending of the line is B. Now you go to the starting and you start adding each time your delta x, which is 3 over 4. So you will say 0 plus 3 over 4 will give me 3 over 4. Now again, I will say 3 over 4 plus 3 over 4 will give me 3 over 2. Then again, 3 over 2 plus 3 over 4 will give me 9 over 4. Now again, 9 over 4 plus 3 over 4 will give me 3. So I stop. Now if you don't like to work with fractions, you can work with decimals. So instead of saying 3 over 4, I can say 0.75. Instead of saying 3 over 2, I can say 1.5. Instead of saying 9 over 4, I can say 2.25 and then 3. Or you can keep them as a fraction. It really doesn't matter. Now you go to each point. You will open brackets under each one of these, and then you will need to find the y. These points 0, 0.75 are the x. They are the x coordinate of the point. Now how will I find the y? You will have to do direct substitution into your function. So when x is 0, you will go to your calculator and you will write square root of, instead of this x, you will put 0. So square root of 0 plus 1 under the root, it will give you 1. Then again you will do the same. You will go to the next point. You have 0.75. So I will put on your calculator, instead of this x, 0.75 plus 1. So I will put square root 0.75 plus 1. That will give me 1.32. Then again I will do with 1.5. That will give me 1.58. Then I will do with 2.25. That will give me 1.80. Then again I will do with the 3. 3 plus 1 is 4. Square root of 4 is 2. Now all you have to do is find the distance between each 2 points. So between this and this, we will find distance 1. Between these, distance 2. Here distance 3. Here distance 4. Again, I need to remember that the formula for the distance is x2 minus x1 squared plus y2 minus y1 squared. So now I will start. I will say distance 1 equal the square root of 0.75 minus 0 squared plus 1.32 minus 1 squared. So I did distance 1 between these 2 points. Again, this is like your x1, y1. This is like your x2, y2. And then you just substitute in the formula. Now I will do distance 2. Distance 2 will be square root of 1.5 minus 0.75 squared plus 1.58 minus 1.32 squared. Distance 3 will be square root of 2.25 minus 1.5 squared plus 1.80 minus 1.58 squared. Now distance is 4, which is the last one, will be square root of 3 minus 2.25 squared plus 2 minus 1.8 squared. Now I will go to my calculator and we will start substituting each one of these into our calculator. So the first one is going to give us 0.815. The next one so I'm just writing the same thing into my calculator. This one is going to give me 0.794. The next one is going to give me 2.25 minus 1.5 squared plus 1.8 minus 1.58 squared, that is going to be 0.782. Now finally the last one is going to be 3 minus 2.25 plus 2 minus 1.8 squared, that is going to be 0.776. Now to find the total length of the curve, so the total length is going to be equal to distance 1 plus distance 2 plus distance 3 plus distance 4. So I'm going to add all the 4 numbers that we got. And the answer is going to come out as 3.167. Now of course this is an approximation of the length of the curve. Now if I want to check, I can find the exact length of the curve by the rule, which is integral a to b square root of 1 plus f prime of x squared dx. So let me check. Again, this is an MCQ question in the final, so you can go ahead and start with this rule and see whether the answer is there. Of course, one condition is that the answers should be a little bit far off from each other. They cannot be very close to each other, or else we will have to do the steps. So A is 0, B is 3 from my question here, square root of 1 plus f prime. Now f prime, I need to derive this one. So the derivative of this is 1 over 2 square root of x plus 1 squared dx. Now if I plug this into my calculator, I should be getting something that is very close to my answer. So the calculator gave me the exact curve length to be 3.16784. So this is the exact answer and this is our approximate answer, and they came out to be extremely close to each other. That's it.